In section 12.3, we discussed measures of dispersion. Range is simply a subtraction of the highest value minus the lowest value. Deviations are calculating how your data deviates from the mean. So these deviations from the mean. And we use that data when we calculate something used often in statistics called a standard deviation. So we're doing a standard deviation for an actual sample. And you had the steps here. You also had an example that you watched, but I wanted to give one more example, just kind of showing you what work to be expected. You know, you don't have to write all of the different steps, general steps down. You can just calculate with what you have here. So let me walk you through an example with 4 data points. Finding the standard deviation with 6, 5, 9, and 8. Notice these are not in order. They don't need to be in order for calculating standard deviation. So first thing you want to do when you calculate standard deviation is calculate the mean. That is an X bar, and you want to use appropriate notation as you're going along and doing this. And for the mean, you add up your data points, divide by your n value, which is just saying how many data points you have, which in this case is 4. So if I add my 6, 5, 9, and 8, I should get 28 divided by 4, which gets me a mean of 7. So that's your first step. Now, as we do these next steps, you can use this table organization like you saw in the videos. It's a nice way to organize your data. It's not absolutely required, but let's just see what happens here. So your data points are the X, we call them just the X values there. It's just saying, okay, what are my data points? I'll just start making the table here. My data points are 6, 5, 9, and 8. So first, as you find the deviations, X minus X bar, you're just taking each of these data points and you are subtracting the mean. So 6 minus 7 is -1, 5 minus 7 is -2, and you want to do your data point first, then subtract the mean. And what's nice at this step, if you just take a moment and add these deviations together, you should always get 0. If you don't get a 0 there, you need to go back and check your work. So that was step 2, finding the deviation of each data item from the mean. But step 3 is to then square that number. So we are going to take that deviation and square it. Be sure that you're putting that in parentheses. Numbers like this you don't need to do on your calculator, but you'll have some maybe where it's a decimal and you need to calculate that with a calculator, and so make sure you're, especially on the negatives, using a parentheses there. So whatever numbers are here, you're squaring, and that's step 3. And then you're going to add those values together. That's what step 4 is asking you to do. So if I add all of those values together, I get 10. So that's what step 4 is asking you to do. Notice step 5, I know sometimes it looks kind of fancy, but we already found this whole numerator. That's what the 10 was. And we're dividing that 10 by n minus 1. Our n is 4. So I'm going to take 10 divided by 4 minus 1, which is 10 over 3, which I would typically leave it as 10 over 3 and take the square root in this form, the 10 over 3 form. However, on My Lab and Mastering, I know they actually did the division and rounded. I don't like rounding in the middle of a calculation, but if you're following their example. They rounded to 2 decimal places and then took the square root from there. So let's go ahead and, because our last step is to take the square root of that number. So notice if I calculated on my calculator square root and I left it as 10 over 3 versus taking the square root of 3.33, let's see how they differ. Square root of 10 over 3, if I round that to 2 decimal places, I get 1.83. If I do the rounded value instead and do square root of 3.33, it's still going to round to this one's going to actually round to 1.82. So the first one is more precise. The second one, since you rounded the division, it's a little less accurate. I went ahead and looked and logged in my lab and mastering, and it appears that they are going to want this value here for standard deviation. They, on their examples, are having you round this value to 2 decimal places prior to taking the square root. So even though this one is slightly more accurate, the 1.83, go ahead and, I believe, to get what they are going to be looking for in the My Lab and Mastering is they're going to have you round your division to 2 decimal places, then take the square root of that number. So, and then round that as well. So standard deviation is approximately 1.82. I mean, it's only differing by 1/100th, so still quite accurate. So we'll use that general practice. Round this number if necessary to 2 decimal places, and then round standard deviation as well to 2 decimal places. You can see in the background I was looking at one of your examples here on your homework, and notice they want you to take the square root of the quotient in the previous step. Something else I'd like to mention also, just what standard deviation is calculating. Standard deviation calculates how much your data varies from the mean. So if all of your data points, like this is number 12 on the homework, if all of your data points are the same, you're going to have a standard deviation of 0. So if you were trying to, because if you wanted to calculate it, you'd have 9 listed out 6 times, and then you would go through and you would do your calculations. Your average would be 9, your mean, I mean, would be 9. But the point is, on something like this, if you understand what standard deviation means, you don't have to go through those calculations. You can say all the data points are the same, nothing varies from the mean, so standard deviation would be 0. I just wanted you to see that as well. And some of your data will be presented differently. Like on number 13, the data is not listed out for you, but you have to realize that what numbers this represents. This represents 17, 24, 27, 34, 37. So your data can be presented in different ways. Standard deviation is calculated using the steps we were using over here.